fundamental thing to understand is when we are talking about the theoretical technology development model, this is basically an academic model and has two very important branches. There is the upper branch where we are trying to talk in terms of the feedback from the market and technology trends, and we are at the same time having some inputs from the internal competencies that the industry has, and at the same time, what kind of innovation is being attempted and how that invention can be converted into, by this particular idea, can be converted into a product or into a system, and therefore how that particular thing can be manufactured. So we start developing about its engineering, we start developing about the technology process, how a repetitive product can be made at a cheaper cost, and how that particular thing can perform as a standard operation. And then we start understanding what are the issues, what materials are needed, what subsystems are needed, where from to get those subsystems, how to arrange the chain, and at the end we come up with the technology. And if we want to make it in-house based upon our internal competencies, it's okay. Otherwise, we transfer the technology to other particular people so that they can produce it and market it. So, understanding basically gives us the capability to understand that we have the technology development model, which is a theoretical one, and the next is where we are trying to talk in terms of technology realization and commercial model. This is a industry developed model, and it has basically four processes: the technology development team, technology review process, structured evaluation methodology, technology review committee. So we have this definitely as a process in which the technology review happens constantly, because the technology development team does not have all the particular this thing. So there is a review board which consists of people who have the understanding of the market, who have an understanding of the technology, who have an understanding of the business, who are senior scientists, and who sometimes we involve external advisors. So we start trying to develop a structured methodology where the lab activities through experiments are converted into a phase plan of manufacture, and then technology development plan is drawn. And at every stage of technology review, we have this expert team operating on the particular outcomes that are defined by the technology development team. So this is how technology realization commercial model happens. And the third model that we're going to discuss is the technology stage gate model, which combines technology and business ideas for technology discovery and interlinks it with six interlinked stages so that a technology discovery of new product and development of structure happens, and it develops ways to mitigate technology and business risk through robust reviews and assessment by external and internal experts. You will see that there is a very great similarity between the earlier model and the current model, and therefore, when we see the particular diagram, we see that it is the only difference is that the process owner now is the inside team. That means this particular technology gate is happening within a firm, and it's their internal process that's being developed. In the earlier process, it could be shared with others, and that could happen, that could give you the ability to understand that we can have this particular team to absorb both the technology as well as the project, and see how the project reviews can be tied up to the technology reviews, and how this can lead to a structured plan for development of the overall technology. In this particular case, the basic stage of activities are information gathering activities by the project team, and then integrated analysis of by integrated analysis we mean that the activities, what kind of things are to be designed, what are the issues in that design, what subsystems are needed, and how those things will process, what will be the inputs to the different stages, and in those inputs what kind of activities will be clubbed together, who will try to talk in terms of one chain and who will try to talk in terms of the other chain. The result is an integrated analysis to each of the gate, and therefore the deliverables are decided. And once we know the deliverables, then we see what is the marketability of this product, what kind of outcomes can be had, whether it will be acceptable, whether the costs are proper, whether the product specifications are valid, and then either we allow it to go to the manufacturing process or we kill the process. So this decision gate is definitely the crucial gate where all the investment that has been made in terms of the human power, in terms of the time, in terms of the energy, in terms of the resources, that can either go into production scale or has to be scuttled and killed so that future losses are prevented. So this way we have the technology gate model where the discovery is passed us through the initial screen, and the first stage is basically project scoping, whether the project is viable, not viable, product that it can result in is marketable or not marketable, then go to the technical assessment, whether that technical assessment means do we have inside means within the factory or within the organization to create this particular technology, or we have to get people from outside, or whether we need outside assistance in order to add to this particular stage, and then go to detailed investigation, make a logical layout plan for the industry. And once that layout plan is done, this detailed investigation gives you the ability to understand whether the application that we are generating, whether it is a new product design or a new process development, or we need to go for a joint venture for licensing. The total technology development model, on the other hand, is based on a system theory approach, and this is an academic approach, distinguishes between technology development and product development. There are four stages of development: primary technology development to improve, enhance main functions of a system, or to create an efficient process or product or service. So the secondary technology development is process, cost, performance, this thing. So what we understand is that initially when a product is developed, it can have basically four stages. The first stage is the ideation, idea generation, and the business models understanding, and therefore how much resources are to be allocated, what are the risks involved, how much amount of commitment can be made. And from that we start talking in terms of what system constraints are there, what are the conceptual bottlenecks, and what are the concept generations. And from here we try to talk in terms of the second stage. So the first stage is basically where we are drawing the primary technology development happens, and this is when the first product or the prototype is developed, and this prototype then goes into the technology selection criteria where different inputs can be converged, and this is the secondary technology development source. So this is how once the product is out, we get the market feedback. Based on the market feedback, we do some other simulations, we do some other maybe change in material, maybe change in process, maybe change in specifications, maybe change in way it will be marketed, or the target market can be changed. And so we develop a range of products, range of versions, range of models, and range of technical competencies from high-end model to low-end model, and therefore the process goes through the cycle repeatedly so that at the end we have a product which is available for a full spectrum of users, which is available across the cultural spectrum all over the world, and which is being given to the people at a beneficial cost so that each one can enjoy the fruits of this product or system. Then there is the global enterprise system model. Technology discovers a technology opportunity, decides the stage to analyze and identify innovation, and basically tries to understand how much we can deploy each stage in order to have effective evaluation and application to value realization, and use multi-pronged approach to ensure selection, execution, and application of innovation idea for achieving organizational gains. Now, you will realize here that this GATES model has four stages. Basically, discover. Once we are able to do vision, somebody envisions a product. Say, for instance, I will tell you a particular story of a transistor. The idea was that can we have propagation of electron in a solid material, and this propagation, can it be controlled, can it be manipulated, and this is possible. And then the relationship between the electron, the hole, and other particular things, so new transistors developed, solid state technology developed, and this was the vision that originally was there. And then the product happened, so the discovery by the Bell Labs, and we decided that it could be made. Texas Instruments came up with a transistor. It was this thing, and gradually, what happened? It floodgates were opened about new products and miniaturization, high efficiency, high productivity, and things like that. So, development effort was basically how process improvements can be converted and how it can ultimately be deployed into a product. So develop, deploy, discover, and decide. These are for the commercial product. So this is how we are going to do it for this thing. So we will see the technology acquisition model now tries to talk in terms of three phases where we identify a technology that can be used, we evaluate that technology, how good it is, how well it can be converted into a proper product, and how well can the industry assimilate it, and how well can it be converted into a basic product, so, which is required in the marketplace and which people will be ready to purchase. So we have three basic routes for this new idea. Either we have a fundamental research or applied research or technology development. So technology development basically sometimes tries to talk in terms of converting this idea fundamental research. So this idea goes into the development of fundamental research. I gave the example of a semiconductor. So the semiconductor was basically an idea which basically Shockley had, and from the Shockley's idea it was converted into a project, and Bell Labs, because of the three scientists coming together, developed this particular product. And once that product was made, the whole applied research was possible, and these particular things were technology transfer happened, new transistors evolved from miniature transistors to large scale transistors, and now we know that there is a whole spectrum of ICs because of this particular technology revolution. So this is how technology acquisition happens through this particular process. The holistic front-end model basically has, again, the phase one is the front-end process where ideation, market analysis, opportunity analysis, and technology analysis happens, and conceptualization is the idea where we are able to try to understand what operational, strategic, information, and organizational objectives can be met, and use this for the technology systemic gate and in front end process. So this is how we are able to convert an ongoing product portfolio into a simulation of design specification, prototype test and validation, volume manufacture, and market launch. So this is the new product design execution, and that's how we are able to do it. So we'll stop here with the big picture model, which is a holistic integrated, again, it's a theoretical model, it's an academic model in which integrated cyclic method for development of projects and uses six cyclic paths based on the kind of technology development. Black path is for ideation, technology and business risk assessment and validation. The red path is for radical innovation process. The blue path for incremental innovation process. The yellow path is for regenerative innovation process. And the black path is for this particular ability to start the innovation cycle again. We'll see that these cycles are something that we have been talking about, especially in when we are trying to talk about software development. We are trying to develop new complex technologies where software, hardware both have to be developed, and where we have to understand what part has to be realized in software, what part has to be realized in hardware. So we try to see that this big picture is the most important and critically most essential model, and this is how we will be able to talk in terms of the technology development processes and models.